I hope this will never happen to you, or to anybody for that matter. But imagine for a moment these two scenarios. Somebody being hit by a bicycle moving at 10 km an hour, and the same person being hit by a truck moving at the same speed of 10 km an hour. The difference in the outcome must be pretty obvious. Well, I don't recommend you to experiment on this at home for obvious reason, so you have to trust me on this. What I'm trying to show you through this anecdote is that when two physical objects collide, what matters is not just the relative velocity between the two, but also the relative mass between the two. Now, two quantities which are derived from velocity and mass immediately come into mind. One is kinetic energy, 1/2 mv². The other quantity is new to us. It is momentum. Momentum is defined as mass times velocity. It is denoted using small case p. Since mass is a scalar quantity while velocity is a vector, naturally momentum is a vector quantity. Its direction is the same as the direction of its velocity component. Needless to say, it has the unit of mass times the unit of velocity. Hence, it is kilogram meter per second in SI unit. When collision occurs, these two quantities are transferred from one object to the other. Take kinetic energy for instance. If object A hits a stationary object B, and B starts to move because it is hit by A, don't we say B gains kinetic energy? Where does B's kinetic energy come from? Obviously, it should have come from A, who is already in motion, and hence possesses kinetic energy. Similarly, since object A is already in motion, it has momentum to start with. When it hits object B, who initially has zero momentum, remember B is stationary initially, it will transfer some of its momentum to B, causing B to move as well. Thus, in short, when collision occurs, kinetic energy and momentum are being transferred from one object to the other. The thing here is that when kinetic energy is transferred from one object to another, it may not necessarily be conserved in the process. Think of a typical collision. Sound is produced. Light and heat is likely to be generated. Sound, light, and heat is energy. Where do you think this energy comes from? It cannot come from anywhere but the initial kinetic energy of both cars. So there is a loss of kinetic energy into sound and heat. Kinetic energy is not conserved. But do note that I am referring only to kinetic energy here. Recall our discussion on mechanical energy and universal energy in Lecture 6. Mechanical energy may or may not be conserved, and in a typical collision, it is not conserved for a reason I just mentioned. But total universal energy will always be conserved. That is to say, if we can somehow measure the amount of heat and sound generated from the collision plus the remaining kinetic energy of both cars, this will be equal to the total initial kinetic energy of both cars before collision. Hence, based on whether kinetic energy is conserved or not in the process, physicists categorize collision into elastic and inelastic collision. Simply put, elastic collision conserves kinetic energy, whereas inelastic collision does not. In any case, both types of collision conserve momentum. Now, I understand that up to this point, it has all just been theory. So we will see how these theories are put into practice through solving typical problems involving collision in the next lecture video.